Okay, let's see. This is try 2 on this. So if it doesn't work, I'm terribly sorry. This is some basics on physics. The links that are in each of these pictures, so like there's a link for each of these pictures. Those are going to be in the annotation in the information below the window. So when you open it up in the YouTube link, it'll probably be underneath it. Underneath the picture, that is. I'll also post these links in a file on Edmodo and one on iTunes U, so you should be able to find it pretty easy. So let's look at what is friction. Friction is the opposing forces moving in opposite directions relative to the object. So if you've ever tried to move a couch or your bed, when you're pushing it with your arms, your legs, and you're trying to move it across the carpet and the legs of the couch are going in opposite directions. So there's where your friction is. The biggest one, the one that's on this slide, is called sliding friction. And this is when you have a match that you drag across the box to make the fire start. That would be sliding friction. And then even snakes, because they don't really have legs, so they scoot along. The second one is rolling friction. This is one that we've seen a couple times on the CBA. If you were to have like a book and you put pencils underneath it to move it, it alleviates some of the force needed to move an object. This is how they think kind of Stonehenge was made, was they use these giant logs to put underneath here, and they would put the big Stonehenge blocks on there and then move it across that way. Your bicycle wheel or your skateboard wheel is rolling friction. It's basically a circular motion. This is a little game where everything is rolled together. That's why I put it there. Help remember rolling friction. The next one is fluid friction. This is when there's some kind of liquid in between the two objects. So like if you were doing wakeboarding, you're not gliding on stagnant or still water because the water is going underneath your board. The water moving between the body of lake water and your board is the fluid friction. This is also found in automobiles and in your knee. There's a little bit of liquid here that keeps your knee joint moving. So if you were to slide a book across a table and watch it, it's going to stop at a certain position. And it comes to a stop because force or friction is stealing its energy, kind of. It's slowing it down because it's pulling at the particles. So balanced versus unbalanced forces. Clearly this is a balanced force. It's equal on both sides. If you're stopped on your skateboard and you're just kind of standing there because there's no movement forward or backwards, you would be considered a balanced force. Unbalanced force is kind of the opposite. It's where one side has more work on it or force on it than the other. So here you've got two little button mushrooms. One's quite a bit bigger than the other one. So this would be, hopefully, you guessed, an unbalanced force. So potential energy, this should be a review from 6th grade. Potential is it's possible, it's positional, it's the amount of energy that an object has when it's at rest. If you think about a roller coaster, the higher up the hill, the higher the first hill on the roller coaster, the more potential energy it's going to have had built over time. When it's actually moving, that's a different energy. So potential energy, if you have your hand out straight from your body and you have a tennis ball in your hand, the tennis ball's potential energy is greatest at that position. And when you drop it, it would go through kinetic energy. Kinetic energy is its moving or actual use of the stored energy. So the example here is cars going down the freeway or the highway are using kinetic energy because they're moving or traveling over a distance. So here's our roller coaster. So as it goes up this first hill is where it's building and storing up its potential energy. And at this position, we'll call it A, it would have the most amount of positional energy possible. Once it's going down this hill, this position B, it's losing its potential energy and gaining kinetic energy. so that as it gets down this little first ramp, it has enough energy stored to move through and use up. So with our yo-yo, if I have my yo-yo in my hand, I have it in its maximum potential or positional energy. And as I let it go, the kinetic energy causes it to move up and down. As it rotates on this little, at the end of the string, it builds some more kinetic energy in so that when you pull it, you actually create some more potential energy. So your vocabulary for this week is going to be to create a vocabulary word art for one of these words. You'll need to include labels. It has to be detailed, like you can't just write gravity and then like something moving, or friction and writing, going left, going right, 2 little arrows. It has to have, as the instructions say, detailed pictures. It must have labels on it in 3 colors, and you have to explain it. So at least 2 sentences that explain your picture. And then your notes have a picture that looks similar to this in it, and you should be able to go through and say, a wind turning a windmill's blade. Is that potential energy or kinetic energy? Well, because it says turning here, I know that it's actual movement, so I would put a check mark in this kinetic energy box. The sun shining on a line of laundry. This one's going to be kind of tricky. This one down here, a roller coaster ride. Those are going to be tricky. So your objective is to go through these 8 little scenarios and put a check mark in each box. Yes, they can be both. No, there are not any that are neither one. So everything has at least 1 box checked. And then there's a brain pop video along with this definition sheet in your notes. I'll put a link to this in the YouTube description so that you can get to that as well. So hopefully that'll go easy. And then these are going to be due on Friday with your vocab art. And the last thing that we're going to do is this think about it. This should go at the bottom of your notes as you're writing it, where your summary would go. We're going to put this think about it. So on a roller coaster ride, when does a car have the most kinetic energy? And yes, you can go back and review your notes. So the bonus for this week is this brain pop video. And I'm not sure if it'll work, but if it does, that'll be kind of amazing. Oh my goodness, it worked. I say it again. Oh my goodness, it worked. So let's go back to this part. If you go through this brain pop video about kinetic and potential energy and fill this out, hand it in by Friday with your quiz, then there are some extra points given to you. So hopefully this helps you. Have a great afternoon.